All right, so today we're in topic 5 and we are in block 2. We are working with adding and subtracting integers. And so in this block today, we're going to represent integer operations with concrete models and connect the actions with models to standardized algorithms. We're also going to show that a number and its opposite have a sum of 0. We're going to be able to understand subtraction of integers as adding the additive inverse. And we're going to be able to add and subtract integers using algebra tiles. And we'll learn what algebra tiles are here in just a minute. So to get started, I want to go back to what we learned the other day when we were in class, and we were dealing with positive and negative numbers that were in blocks. And in these blocks, the yellow blocks represented the positive integers and red blocks represented the negative integers. So if I were to ask the question, what would it look like to model for, and this is on page 137 in your workbook, how could I model the number 4 with those yellow or red tiles? Remember that the yellow tiles are positive, red tiles are negative. So I'm looking for like the number of tiles I would need to represent the number 4. Go ahead, Devin.
4 yellow tiles?
Correct. We would need 4 yellow tiles. Now, thinking on what Devin just said, what would we need to represent the number -4? Somebody other than Devin. Go ahead. Grayson.
4 red tiles?
Correct. And that would equal -4. So that's how we're going to actually be using algebra tiles today to model positive and negative integers. Okay, so to get started, the first thing we're going to do is we're going to continue learning about Archibald. Yesterday we talked about Archibald and all the things that he wanted to do. Well, today we're going to see some other things. All right. Remember Archibald the ant, he wanted to go travel everywhere. Okay. Well, now Archibald's trying to decide if he wants to go to Spain or Greenland. So we're going to look at the positive and negative aspects of both of these places that he wants to take his adventure to. And we're going to see which one the positives or negatives outweigh the other so that we can figure out where he wants to go. So it says that Archibald's trying to decide where he wants to go. All right. He wants to go to either Spain or Greenland. Now, he makes a list of all the positive aspects and all the negative aspects. And each item has equal value to him. So just kind of think of it as they're worth 1 point. So we're going to use that so that we can figure out which place he should choose to go. So if you would, Angel S., would you read all of the positive and negative aspects of Spain? And let's put a +1 for the positives, and we'll run a -1 beside the negative aspects. So go ahead whenever you get ready.
So positive for Spain, no Spanish.
Okay.
Negative is visited Spain before.
All right.
A positive is airfare is expensive.
Is it expensive or inexpensive?
Inexpensive.
Okay.
Negative is might run into ex-girlfriend Antonia. Positive is love the food. Negative is might run into Antonia's big brother.
All right. So it looks like Archibald and Antonia had some type of falling out. I don't know what happened, but it sounds like Big Brother's ready to collect on a butt whooping or something.
He's not too happy.
No, not at all. So looking at these, are the positives or negatives outweighing the other here?
No.
So what's happening?
They're both
Say that again?
They're both equal.
That's right. They're equal to each other. So in other words, they're really canceling out, right? So it's like that's 0, that's 0, this is 0. So Spain, they kind of have a neutral score of 0. All right. So let's look at Greenland. All right. Let's see. Brendan, tell me the positive and negative aspects of Greenland. Go ahead, Brendan.
You said for Greenland?
Yeah.
Oh, you want me to read it?
Yeah, I want you to read the positive aspects and the negatives.
I have never been there. Cool new animals, can learn to dog sled. Have never dated anyone from Greenland. And the negatives are I can't speak the language, cold, and long plane rides.
All right. So looking at this, do the positives or negatives outweigh the other on this one?
Yes, the positives outnumber the negatives.
All right. How many more are there, Kalia, that are positive?
1.
All right. That is 100% correct because these cancel each other out right here, and there's one left over that is positive. So we could say that Greenland has a score of what?
1.
1. And so based off of these scores, where is he going to want to go? Asia?
Greenland.
Okay. Asia, do you agree?
See, my thing is that Spain is so big, and he's saying might run into his ex-girlfriend, so that's a very small chance.
It is a small chance. Asia, where's he wanting to go? Come on, Asia. Talk to me. Talk to me, girl. Does he want to go to Spain or Greenland? I see you looking at me, Asia. I know you can talk. You can do it. Everybody's staring at you right now. We're not trying to make you feel awkward, but we're all waiting to hear your answer.
Mr. Martin.
Yeah. What's up, Devin?
Nice drawing.
Thank you. Thank you. All right. So, Asia, we were waiting on you. You're not really helping us out right now. So we don't know where this person's going to go. Kalia, help her out and tell her where we're going to go.
Greenland.
We're going to Greenland. Archibald is looking for a new date. That's what it says. He's done with Antonia. It's time to go to a new country because everybody in Spain is just, they're Antonias. All right. So, all right. Does that make sense, Asia? Throw me a thumbs up or something.
Yes.
All right. Good deal. All right. So we're going to move from this. And you should have been able to answer questions 1 and 2 on page 137. Now, the way that you could have done that is you could have drawn like 4 squares to represent positive numbers. You could have drawn 4 squares to represent negative numbers. You could have drawn circles to represent positives. You could have drawn triangles to represent negatives. I mean, it's your imagination. You could have drawn stick figures, whatever makes you happy. You know, you could have done plus signs and negative signs, whatever you like, you could have done. Okay. So that's what you needed to do on page 137 for questions 1 and 2. So now we're going to go to page 3, and on not page 3, we're going to go to page 2. And we're going to talk about additive inverses and zero pairs. So, Levi, would you mind reading that for us, please, sir?
You can think of integer addition in the same way that Archibald thought about his trip. One positive and one negative balance each other. In effect, they cancel each other out. You can represent this balance with the equation 1 plus minus negative 1 equals 0. You know that numbers negative 1 and 1 are opposites. They're also called additive inverses. Two numbers are additive inverses if their sum is 0. When integers such as negative 1 and 1 pair up to form a sum of 0, they are called zero pair. Here's an example with tiles.
Thank you. So looking at this, 1 and negative 1, they do what to each other?
They cancel each other
They
out.
cancel each other out. So this makes 0. All right? Does that make sense to everybody?
Yes, sir.
So if you have one yellow and one red, that equals what?
0.
0. Because that's having +1, -1. So if Levi gives me $1 and then I give him the dollar back, I don't have any money. All right? I'm still stuck at 0. All right? So let's take a look at page 3, and we're going to actually put this into play. Okay, so these are in your next workbook page, and we're going to be answering questions, let's see, 3 through 5, I believe, in your workbook. So looking at this, the first thing that it wants us to do is it wants us to represent -4. So how would we represent -4, Satari? Help her out, Vincent.
For the -4, you would put 4 of the negative ones in there, and then for the +6, you would put 6 of those.
Good job.
6 of the regular ones.
Whoa, that looked like too many. 1, 2, 3, 4, 5, 6. Gotta get rid of some. There we go. All right, so when we do that, what's happening, Vincent? What do I need to do with these in the center right here? What's going to happen to those? They're going to do what to each other?
Combine.
Not combine, but they're going to do what, Devin?
They're going to cancel each other out.
That's right. Vincent got it right whenever you said it. Good. They're going to cancel each other out because 1 minus 1 is always 0. So when we remove those, what are we going to be left with, Vincent?
2.
Yes. All right. So it says we did a nice work. It says we correctly used the algebra tiles to demonstrate that -4 plus 6 equals 2. All right. So we're going to look at this next one. We're going to get Miss Kalia to lead us. Kalia, tell us what we should do.
For the 5, you would need 5 of the yellow ones.
Okay.
And for the -9, you would need 9 of the red ones.
6, 7, 8, 9. Is that going to work? Did I do that right? No. I was waiting on a no, but
It's
nobody said it.
-9 first.
There we go. Now I got it right. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So what do I need to do now, Kalia?
They'll cancel each other out, and you'll be left with the 4.
Good job. And since I'm left with 4 negatives, my answer is going to be negative what?
4.
Correct. How's everybody feeling so far?
Good.
Good. Pretty confident?
Good.
All right. Okay, so looking at the next one, Khalees, I want you to work us through this one. What would we do first, Khalees?
You put 3 of the negative ones and 4 of the negative ones too.
All right. Oops. And what do I do with them?
Add them.
Yeah, we're going to add them together. So let's just count them. 1, 2, 3, 4, 5, 6, 7. They're all negative. So my answer is what?
7. -7.
Good. -7. Anybody confused about that?
Nope.
All right.
No.
Cool. We're moving on then. Everybody should have those written down. in their workbook knocked out. All right, so we're looking at number 4. All right, and on number 4, what we're going to do is we are going to get Miss Rachel Fincher to read this for us and explain it to us. Come on, Miss Rachel, read that for us.
Which one?
All of it.
Okay. You have modeled 3 addition problems with algebra tiles. Take another look at the last problem. -3 plus -4 equals -7. Think about the workspace you created for this problem. Why is the answer a negative number? After removing any 0 pairs, there were only negative tiles in the workspace. Now think about the other 2 problems where you added a positive and a negative number. Think about the workspace you created for -4 plus -6 equals, -4 plus 6 equals 2. Why is the answer a positive number? There were more positive tiles than the negative tiles on the workspace. Therefore, after removing of 0 pairs, there were positive tiles left over. Now think about the workspace you created for 5 plus -9 equals -4. Why is the answer a negative number? There were more negative tiles than positive tiles in the workspace. Therefore, after removing any 0 pairs, there were negative tiles left over.
All right, so looking at this, out of what we've looked at so far, when we look at this right here, we have -3 and -4. These both have the same sign, right? Since they both have the same sign, that means that our answer is going to be negative. Okay? Now, in this next case, it says that we have -4 and +6. Now, is -4 or +6 further from 0 on a number line? 6. So since 6 has the greater absolute value, that means that our answer is going to be positive. Now, Rachel, were you able to read this part right here?
Yes, but I said negative. I said just -9.
Okay. All right. So right here, when we have 5 plus -9, we know that -9 has a greater absolute value, meaning a greater distance from 0 than 5. So that means that our answer is going to be what sign? Negative. All right. So when it says what is the relationship between the number of each type of tile that you have and the sign of the answer, whichever part of the problem, the addition sentence, has a greater absolute value, that's going to be the sign that your answer is to your addition problem. All right? If they both have the same signs, it's going to be that sign when you're adding, okay? So same signs, we add and keep the sign. All right? Does that make sense?
Yes, sir.
All right. And actually, on opposite signs, we're going to subtract and keep the sign of the number that has the greater absolute value. So that's actually important to know. So I'm going to say that one more time. Opposite signs, we subtract and keep the sign of the number with the greater absolute value. Remember that absolute value is the distance that a number is from 0 on a number line. So let's look at page 5. Now this is where it gets pretty interesting. We've been doing addition. Well, now we're doing subtraction. First problem, super simple, but then it gets interesting, okay? So first thing that we got 5 minus 3. And they thought it was so difficult that they made a video for us. So we're going to watch the video. So the first thing that we notice is they have used 5 positive tiles to represent the number 5, okay? Now, we're going to select 3 positive tiles and remove them. When we do that, we're going to see what will be left over. So after 3 positive tiles are removed, what's left?
2.
2.
Great job. Hopefully that didn't lose anybody. If it did, we got a lot of work to cover, all right? So let's look at the next one. I think we're all good right now, hopefully. If you're good right now with what we've learned so far today, throw me a thumbs up.
I don't have the nod extension, but I'm good.
All right, good. Good deal. All right, I got a couple of thumbs down. Remember, 5 minus 3 equals 2. I'm just joking. We didn't get any. All right, here we go. Now, we're going to look at part 3. And it could get confusing now. I'm going to be honest. Some people are going to get a little confused, but it's okay. It says we're taking 3 and we're going to subtract 5. Okay? Devin's raised his hand. What are you thinking, Dave? Devin? Grayson did too.
I accidentally raised my hand, but
all right, Grayson.
I will tell you what I think.
Hold up, Devin. Grayson raised his hand too. Let's see.
Wouldn't it just be the same as 5 minus 3?
All right, explain.
Actually, hold on. Never mind. Now that I look at it.
All right. What were you thinking, Devin?
I mean, I would think it would be, I mean, I need to, let me think a little bit longer.
Okay.
Wait, are we subtracting 3 minus 5?
We are doing 3 minus 5. You're right.
This question make my brain hurt.
That's good, Ty Marion. That means it's growing. All right, so I'm going to replay that just so that makes sense again. All right, so we started with 3, and then it says we're going to subtract 5. So
Wait, Mr. Brian, I think I got an idea.
They're bringing us 1. All right, Vincent?
I think you would do 3 minus 5, and it would be negative 2.
You're 100% correct, Vincent. Great job. Now, how did you know that?
Because like what Grayson and Devin were saying, it's basically the same thing around, but it's negative. So 5 minus 3, that's 2, but now it's switched around, so it's negative.
Correct. And that's kind of like what we talked about earlier. We said if it's opposite signs, say for instance, this was 3 plus negative 5. We could subtract and keep the sign, right? So 5 minus 3 equals 2, but we know that negative 5 is further away from 0 than 3 is, so our answer would be negative, right?
Yes, sir.
Yeah.
You know when you did that Khan Academy assignment? Or
yes.
You asked us if we can do it?
Yeah.
It actually does this, and it's basically like keep, change, flip. You keep the first number, you take the subtraction symbol and add plus, and then you switch the second number to its other side.
Yeah, to its opposite.
If it was negative, you'd switch it to positive, and if it was positive, you'd switch it to negative.
All right, I'm interested to see how that's going to work for us here in a minute. I think what you're talking about is whenever. Okay, yeah, okay, I got you. I see what you're saying. So that would be 3 plus negative 5.
Yeah.
I got you. Okay. And so when we remove, not those, we got to remove these 5 positives. We're left with negative 2. Okay. So this is kind of what Devin was talking about. He said, you're going to take the sign, you're going to change it to addition, and then the sign of the number is actually going to change. So when that takes place, this would actually be negative 3 plus a positive 2. Now, I talked about this at the beginning of class and I wrote it in our chat. I said that when subtracting a negative, we're going to add the opposite. And that's basically exactly what Devin explained to us when using Khan Academy, okay?
It's sort of like the keep, change, flip method that we use with fractions.
Mm-hmm. So you're just swapping the signs.
Yeah.
I got you.
Yeah.
Cool. All right. So what we're going to do is we're going to start with our original. Now we know that we start with negative what?
-3.
All right. So we got 1, 2, 3. And now it asks us to take away 2 of the negative 2's. So if I take them away, I'm going to do what?
Subtract.
So I'm going to subtract them, or I'm removing them. Okay. So when I subtract those away, they're gone. So what am I left with?
-1.
Good.
-1.
Anybody have any questions so far?
No, sir.
All right. Well, let's try this one. This is 5 minus -1. All right. Well, in order to do this, we're going to have to represent 5, and we're going to have to be able to represent that -1 on there at the same time. So, yes, Grayson.
Wouldn't it be 4 because you're just subtracting 1 from it?
All right. So it seems like that. But remember, it's minus a -1. So anytime we take away a negative, it's like adding a positive number. Devin, did you have something to add to that?
I was going to say that I disagreed with Grayson.
Why?
Because, like, it's -1, so, like, when you subtract it, it's basically like adding it.
Okay. All right. So what I like to do is anytime I see these signs right here that look like this, minus a negative, what I like to do is I like to change it to an addition sign. So this is really, if you rewrite it, it would be 5 plus 1, which is going to equal what?
6.
Yes. All right. So that is actually our answer, but we're going to show it using these algebra tiles. Now, sometimes it gets difficult to show this with algebra tiles, so we're just going to do our very best, okay? Sometimes it's hard, sometimes it's not. So we know that there's 5, okay? But we got to have a -1 up there. So in order to do that, we need to make a 0 pair, okay? So I'm going to add one more 1, and that's going to be my 0 pair. So when I have this 0 pair, I have 5 right here, right?
Yes.
Well, now, since it says 5 minus -1, I'm going to take away that 1 in just a second. I got to do this first. All right. So it says, are you able to subtract -1? If not, find another way to represent 5. Remember to add 0 pairs. Well, I got to do that. So I got to have -1 up here, but I can't take I can't take -1 away right now. So I have to make a 0 pair. So when I make that 0 pair there and I take that -1 away, look what I'm left with. How many?
6 positive.
Yeah.
Or 6.
So it's kind of weird how that works with showing it with algebra tiles, but it does work. Because if you take away a negative, you're adding. Okay? So remember, anytime it says subtract a negative number, we're adding the opposite. So remember, anytime you see this sign right here, see how it kind of looks like the sleepy moon face or something? Just take that, put a plus sign. Okay? So let's look at the next one on number 7. Now, this is the most complicated problem to show on here. Okay? I'm going to be honest with you. I have struggled with showing this on here all day today. So, luckily, since y'all are the last class, I might be able to do it. All right? Grayson's raising his hand. He might be able to do it. What do you think, Grayson?
Okay. So I think that it would be -3, or no, it would be 3 positive.
Correct.
Positive 3. Okay.
You're right, Grayson.
I don't know about how to represent it.
All right. Well, you are 100% correct. That is the answer. Representing it is a little tough. Devin, he's thinking he might can represent it. What are you thinking, Devin?
I don't know how to do it.
So normally, so I did it the keep change flip way. So if you did -5 plus 8, you would get -3. I mean, you would get 3.
Correct. All right. Now, looking at this, it says start the subtraction problem by modeling the integer -5. All right. So the first thing we got to do is we got to put -5 up here. All right. So we got that. All right. Now it says, are you able to subtract -8? If not, find another way to represent -5. Well,
Now, wouldn't you put now 8 yellows?
all right. Let's do it.
Then do the 0 thingy.
All right. Now, if we do this,
I mean, it will
this,
get our answer.
Levi, this is how, I mean, it works this way, but for some reason in the computer, it won't allow us to put our answer like this. All right. Because it wants us to subtract -8. So we're going to have to change how we do this. Instead of doing this, we're going to make 5 0 pairs, and then we're going to throw some negatives up here. Because I want to be able to remove that -8. So let's see what I got. We got 1, 2, 3, 4, 5, 6, 7, 8. And if I remove these, though, I can't. If I remove these, I'm going to still have, I would have +5, wouldn't I? Would that work? No.
No. Wait, what?
So that wouldn't work. So what would I need to do?
How did you get 3 at the bottom? Did you subtract 5 from 8?
I did -5 plus 8. Go ahead, Grayson.
Wouldn't you have to do +8 and -8, but add 3 more positives? Maybe.
Yeah, so the way that I put it in here, and I don't know if it's the right way to do it, but I got 1, 2, 3, 4, 5, and then I'm going to do 1, 2, 3, 4, 5, and then I'm going to do 6, 7, 8. All right. Now the reason
How did you come up with that?
All right. Well, I'm going to be honest with you, Grayson. I didn't come up with it. It was already on the computer like that because I don't understand why they do that. But what they do is they come in here and they subtract these. So that's 1, 2, 3, 4, 5, 6, 7, 8. All right. If I subtract those, let's see what it says. Your workspace normally represents -5. Make sure you're representing 5 correctly before you try to subtract -8. It ain't working yet. So what do we need to do? 1, 2, 3, 4, 5, 6, 7, 8. What if we just take those 2 off? That would be 8 and 3. But I don't understand why. I'm going to be honest. I've tried this all day today, and I just don't understand it. I don't like the problem.
So this was the problem that was confusing.
Yeah, I just don't understand why it's like this, because that's why I said if you do math the way that it was created, this says -5 minus -8. Well, we said that anytime you subtract a negative, we're going to add the opposite. So that's really -5 plus, what's the opposite of -8, class?
8.
8. And if we do this, remember they're opposite signs, so we are just going to subtract and keep the sign of the one that is further away from 0. Is 8 or -5 further from 0?
8 is farther away.
Correct. And 8 minus 5 is?
3.
3.
Ain't that a lot easier than trying to do any of this junk?
Yeah.
Yes.
I
Wait.
understand it, but I don't understand why they make us use those tiles when there's a way simpler and
Yeah,
easier.
and needless to say, I'm not going to make you use it that way. Now, Grayson said it the best way. Levi said it the best way earlier. All you would have to do is -1, -1, -1, okay? And then you're +1, 2, 3, 4, 5, 6, 7, 8. All right? Oh, this was supposed to be -5s. 1, 2, 3. Well, that cancels, that cancels, that cancels, that cancels, that cancels. So you're left with 1, 2, 3. Isn't Levi's way easier?
Yes.
Yes. I don't know what they were trying to show. I don't really care. I just want us to get the right answer. Sorry I wasted y'all's time. I've wasted my time all day trying to figure that out, but oh well. Have to talk to some genius, I guess, because it ain't happening with me. I'm doing it the easy way. All right, so let's look. Do what, Grayson?
That's why Google is invented or was invented.
I guess.
Google is a wonderful thing.
I don't know that Google could explain it to us, to be honest. All right, so let's see what we got. We're going to go to number 6. And you'll see what I'm talking about in just a second, because it actually explains that problem, but it's still, you're going to be like, I ain't seeing it. All right, so go ahead, Mr. Timarion. I want you to read all this for us, please, sir.
Okay. Wait.
You have modeled?
You have modeled several subtraction problems with algebra tiles. Take another look at this one. 3 minus 5 equals -2. Think about the workspace you created for this problem. Why was the answer a negative number when you subtracted a positive number from a positive number?
Keep going.
The value being subtracted, ain't that just +5?
Yeah.
+5?
Correct.
+5 was greater than the original value of the workspace. +3. It is like going into debt. So your answer is negative.
All right, so that means that you have $3, but you buy something that's $5. Well, if you have $3 and you want to buy something that's $5, that means you need to come up with how much more money?
$2 more.
$2 more. So you're in debt $2 or $2. All right. Natalia, I want you to read the next one.
Where it says, now think.
Yes, ma'am.
Now think about this one where you subtracted a negative number. -5 minus -8 equals 3. Think about the workspace you created for this problem. Why was the answer greater than -5 when you subtracted from -5? When you subtracted a negative, you use more 0 pairs and then only remove negative tiles. You end up with lots of positive tiles, so the value increases.
All right. So looking at this.
I kind of get it a little bit.
Okay, well, you explain it to me, Levi.
So one thing I don't get is how you get 10 on the negatives, but one thing I do get is since it says -8 on the right one, you can do -8 from 10 to -8 from 10.
Correct.
You get 2 and cancel out the ones. You get 3.
Oh, now I see it because you're like -10, and then you take away the 8. But I don't understand how you got 10. But when you take away the 8, you have 2 negatives left. And if you cancel out the 2 negatives and the 2 positives at the top, then you're left with 3 positives.
Yeah, I think it's similar to like, you remember whenever you used to use number bonds and you would have to borrow from one place so that you would have the tens so that you could take away.
Yes.
I think that's kind of, they're using this kind of in that situation.
Like when you're subtracting thousands and like you have to do like 0 minus 6, and then you like have to borrow from your neighbor and do all that.
Mm-hmm. Is that what you were trying to say, Levi? Yeah.
Yes, sir.
Well, why don't you say it one more time for everybody?
Okay, so you get 10. I mean, I guess you just do negative 10 plus negative 10 and just turn that into positive. I really don't know how to get to 10. But then you do the negative 8 minus 8 because on the right is 8. And you get 2. The negative 2 is on the tops. And so you cancel out each of those with the negative, the two positives on the top of the left one. And then you get 3 positive.
Sounds great. Fabulous explanation. Fabulous explanation. If any of y'all's minds feel like mine, you're definitely learning. All right? So, I'm going to stick to what I know. If you have to subtract a negative, we're going to add the opposite. So, instead of subtracting negative 8, we would add positive 8. And it's so much more simple than the way that this is set up. Don't you agree? Or do you disagree? If you agree, raise your hand. Shake your hand. Throw a thumbs up. Something. All right. If you like the Levi way on the thing, you can, I don't know. I don't know. I know it's not me. All right.
I understand it. Like I understand what Levi said, but I still like don't know how to get the 10.
Yeah, I just don't know how to represent it that way.
I think you just double the left. I don't know.
Yeah.
I'm lost on how to get the 10, but like I get what he's saying. Like
yes. I mean, it makes sense cutting them out like we're talking about. And that's what I was trying to do on there. But like Grayson was asking, he was like, I don't understand why you're doing that. And to be honest, I have no idea either. I do it my way.
Okay, I might have a theory.
All right.
Not really theory. So you know how you say how you have to change the negative to a plus on the right one? What if that's what you had to do in their way, like on the left, and you do plus 5 and then change the negative 5 to another plus? I don't know what I'm getting to at this, but
I just don't understand when the 10 comes into play.
You mean like multiply everything by -1?
I'm not sure.
I mean, I get it, like once you have it, but like where does the 10 come from?
That would give you 5 minus 8. And 5 minus 8 would give you -3. Now, it wouldn't work that way, Levi. I see what you're talking about, but it wouldn't work that way. That's why I like just using the rule. I think as long as you can remember that rule, and I'm going to make sure that every day that you hear it from me and that you write it down in your book. But who can tell me what the rule is?
Well, I mean, I can.
Okay.
Well, I have I mean, I can, but I can't.
All right. Well, it's in the chat box.
Oh, well, when subtracting negative numbers, add the positive. Add the opposite.
That's pretty good.
Sort of like how I like to call it keep, change, flip.
All right. But that's kind of a little bit different, but I understand. Yeah. So he's saying that you change the sign and then you're working with the opposite of whatever that number is. Okay. So what we're going to do is I have put you an assignment in the computer. Y'all actually did problems 1 through 3 yesterday, but we're going to do problems 1 through 5 in more practice. I actually got it in the computer already so that you can get credit for it. So the way that you're going to go to this is you're going to click My Agile Mind. And when you click My Agile Mind, you're going to click Assignment. So when you click that assignment, you're going to have this right here. We actually answered the first 3 questions together in class yesterday, I believe. So should be able to roll through those first 3, and then you'll have 2 questions to complete. And after you do that, we'll review over those in just a minute.
Mr. Martin, it won't let me go back to it.
Won't let you go back to what?
The assignment, because I did it earlier today.
Okay, that's fine. That's fine. Just wait just a minute and then we'll review it, okay? All right, so we're going to run through this pretty quick. Grayson, the opposite of 3 is?
3. -3, my bad.
There you go. The opposite of a number
So
is
easy.
known as its
Additive inverse.
Additive inverse.
Good job. All right, number 2. Hagen Hemmons. The value of workspace A is what?
I can't see it on your screen, but my stuff has been loading this whole time because I was having internet problems.
Uh-oh. All right. Well, let me call on somebody else. Hopefully they'll help you out. Hermione, the workspace A, the value of it is what? I'll tell you what, let's make it easy. Why don't we cancel what we can? Let's cancel these, cancel these, cancel these, cancel these, and then we'll just circle the other ones. So we got 1, 2, 3, 4, 5. They're all negative. So what's it going to be, Hermione?
5.
Positive 5?
-5.
There we go. All right. And then the workspace B, Malik, would be what? We're going to cancel what we can cancel. We're going to cancel those, cancel those, cancel these, cancel these. What's the value of workspace B, Malik? Malik needs help. Natalia, what's the value of workspace B?
+2.
Yeah. 1 and 2. So it would be 2. So looking at this, all we got to do is tell which workspace has a greater value. All right. So, Sophia, which one has a greater value, -5 or +2?
+2.
Correct. So 2 has a greater value than -5. Oh, I can't put that. I got to put workspace B has a greater value than workspace A. All right. Let's keep on moving. Rachel, try this one. Identify the value of each workspace, then tell which workspace has a greater value. What do I need to do, Rachel?
You need to cancel out what you can.
All right, so let's do that. So those would cancel, those would cancel, those would cancel. Wow, and these would cancel. So what is workspace A?
0.
Good job, Rachel. What's the value of workspace B? What can we do with it? You want to do the same thing? Cancel out some of them? All right, so what are we left with?
-3.
Great job. So which one has a greater value, Rachel?
Workspace A has a greater value than workspace B
Why?
because 0 is closer. Well, that's more than -3.
Good. All right, let's look at number 4. All right, let's go with Miss Satari. Miss Satari couldn't hear me earlier. Satari, can you hear me now?
Yes, sir.
All right, Satari, it says create a number sentence that represents the workspace. Fill in the blanks. All right, so what do we have in the first part, Satari?
-12.
All right. You did that fast. How'd you do it so fast? What'd you do?
I was already working on it.
Oh, cool.
Yes, sir.
All right. And then what do we have for part B?
+9.
Okay. So what would we do to find our answer? Do you want to cancel them out like we did earlier?
Yes, sir.
All right. So let's do some of those. Let's take both of those rows would be gone because it's 2 and 2, right? And then
Yes, sir.
that's 3 and 3. So what are we left with?
-3.
Perfect. Anybody have a question how she did that one? Did anybody do it differently? Everybody feels confident? Give me a thumbs up on the diddle-majigger. Unless you're the person that doesn't have nod, and then you just say, I got it. They didn't say I got it. It's not good. Kalia, you there? She must have took a bathroom break. All right, here we go. Next problem. Grayson has raised his hand. He wants to do this one. All right, Grayson, tell me what to do.
So it'd be 8, like positive, -10, -10,
Okay.
and then it'd be -2.
Correct. That looks perfect. Could we have canceled them out if we wanted to? Yeah, we could cancel out 4 and 4, and then we're left with what?
2.
Those 2 negative ones, right? So that works out perfect.
Yes.
All right. Does anybody got a question?
No, sir.
Everybody feels pretty confident.
Yes, sir.
All right. So what I want you to do right now, I want you to come up with, this is actually a higher order thinking question. What that means is we're going to actually use our mind and come up with a real world situation for this number sentence. 15 minus 25 equals -10. I want you to come up with a real world story that would go along with that right there. Grayson's already raised his hand. Give me one, Grayson.
So say you want to buy like just a scooter. I don't know.
Okay.
Say you want to buy a scooter. Okay. It's $25 and you only have 15. So you're -$10 or you're $10 in debt. So it'd be -10.
Okay. Devin, what was yours?
Okay, well, I basically had the same thing that Grayson had, so I'm going to do another one. And so, say your rent is $25 and you only pay $15. You're $10 in debt.
All right. Satari, what was yours?
Basically how they said it, like how if you was trying to buy something from the store that was $25, but you only paid 15, then you'll need to come up with $10 more.
Perfect. Does anybody have a question for those 3? Does everybody feel pretty confident in what those 3 said? I do. All right. So y'all give me a thumbs up, everybody, if you feel good. If you don't feel good, throw me a thumbs down. Looks like most of us got it going on. All right. So, my boys and girls, I wish you a fabulous evening. Most of you should be done with your homework because we just did it. All right. So, I'll see y'all later.
Bye, Mr. Martin.
Bye-bye. Y'all have a great day.
See you tomorrow, Mr. Martin.
Bye.
Bye-bye.